Now friends, we will see the third part of this module, that is the study of passive components, and that is nothing but the inductor. So the objective is what is mean by that inductor, then inductor types, then how the inductance is to be determined or identified, material use, again series and parallel equivalents of that inductor and various applications, right? So here first of all we'll see what is that inductor. Inductor, it is nothing but a coil of, we can say, pure conductive material, metal, uh, wounded on somewhat ceramic or non-conductive materials. So rating of that inductor, it is mostly in given in microhenry or in millihenry. So just opposite to that of capacitor, here simply we can see it passes DC and blocks AC signal. Why or how, that also we will discuss later on. So that inductors are mostly used in filters and tune amplifiers. So this is the application or use of that inductors. Inductors are available as a fixed as well as variable inductors you might have seen, and basically that variable inductors are known as a IFT, that is nothing but intermediate frequency transformers. Again, the color coding is same as that of somewhat resistor, but only the difference is while calculating that inductance, it is multiplied by micro, that is nothing but 10 raised to minus 6. In case of capacitor, that by default multiplier we seen that was pico, that is 10 into 10 raised to minus 12, but here we have to take that multiplier as micro, that is 10 raised to minus 6. The reactance offered by the inductor to the given applied input signal, it is determined again by using the simple formula, that is XL, which is equals to 2 pi Fl. So again, same method of capacitor, it is a frequency dependent component, right? So by changing the input signal frequency or applied signal frequency, the reactance of this component, it will going on to change. The difference between reactance offered by capacitor and reactance offered by inductor, it is that in case of capacitor, what we see, the reactance, it is inversely proportional to applied input signal frequency, while over here it is directly proportional to the applied input signal frequency. And that's why you will observe XL equals to this formula as 2 pi Fl. That means XL is directly proportional to F, because the remaining terms are constant. 2 pi is constant, and L, it is nothing but the inductance of that selected inductor, which will remain constant. So the reactance offered by that inductor, it will be dependent, directly proportional to applied input signal frequency. And that's why here we can say, thus for DC signal that is having again the frequency as a 0 Hz, the inductor, it offers ideally 0 reactance, that is, it acts as a closed circuit. While in case of capacitor, what we see for DC signal, that capacitor is acting as an open circuit, because Xc equals to infinite, while over here XL equals to 0. If you calculate the reactance of this inductor for 0 Hz frequency, then it comes as 0 ohm, right? So while for AC signal, the reactance is finite and the value depends on frequency of applied input signal and the inductance of that inductor, already I told. So when signal passes through the inductor, again that inductor, it stores the energy, same as that of in case of capacitor also, that capacitor also stores the energy when the voltage is applied across that capacitor. And but the difference is that whenever the current flow through the inductor becomes 0, that means or the applied input signal goes to 0, what happens with inductor, the stored energy of inductor, its polarity, it gets reversed. It do not occurs in case of capacitor. That is the difference between the energy stored by inductor and capacitor. Here you can observe, I taken all these images from again using Google. So here you will simply observe there is a copper coil wounded on various non-conductive materials, like standard bobbins are there, then ferrite cores are there in circular as well as in square shape or in various different shapes, right? So according to the required inductance, that is L, it is calculated, the number of turns as well as the gauge of that copper wire, it is calculated, and accordingly that inductor is formed. One more thing over here I want to highlight. See, it looks like a transformer. Generally you might have seen such type of component as a transformer, step down transformer, right? Now the difference between the shown inductor and whatever you see is only that here you will observe there is only one coil. only two terminals are there for that wounded coil, that is starting terminal and end terminal, is it? But there is no secondary. That means a single coil is there, and which is stamped by using that various shapes of that plates, E shape and all that, is it? Similarly, over here you can observe there are two inductors wounded on a common body, is it? So there are two terminals. This one is a separate inductor, this one is acting as again separate, like this. So according to Neil, that conductive wires are wounded and that inductor is formed, right? Next one, again the inductors are also available just like or it looks just like a resistors. So the color coding is also almost same as that of CFR type of resistor. Only the difference already I told, that multiplier it is to be taken as 10 raised to minus 6, right? So here you will observe the first color is red, then violet, then brown, and last band is for tolerance. Over here it is shown as a black, and that's why the value of that inductor, it is calculated as first two colors as it is their concern numbers, that is 2 and 7, red that is 2, for violet it is 7, into 10 raised to the third number is power. So as it is a brown color, that's why 10 raised to power is 1. And as already I told, this is by default. It should be taken by default, right? In case of inductor. In case of capacitor, again I will highlight. In case of capacitor, what we done, we taken this multiplier, by default multiplier as 10 raised to minus 12. That is pico. Over here it should be micro, that is 10 raised to minus 6. You have to remember this thing. Okay. So finally, the value of this inductor is 27 into 10 raised to 1 means 270, and 10 raised to minus 6 Henry, that means micro Henry, simply, with the tolerance of that last band, that is nothing but black. For black, the color assigned is 0. For that black color, the number assigned is 0, and that's why the tolerance is 0%, right? Now same as that of resistor, again the series and parallel equivalents are calculated. It is same as that of resistor. Whenever inductors are in series, simply the equivalent is the addition of inductances of all that inductors. So as shown over here, L1, L2, L3 and L4 are connected in series, and by using one LCRQ meter, that is to measure the inductance of this total series combination, that L total equals to simply the sum of all that, that is L1 plus L2 plus L3 plus L4. And if again it is connected in parallel, same as that of resistor, using LCRQ meter over here for inductance measurement, the L total, it comes as L1 into L2 into L3 into L4 divided by the total inductance, right? So this is the exactly same as that of resistors. So in summary, you might have understood what is that inductor are in different sizes and shapes, and that inductors are available or can be manufactured or in standard form also that are available just like a resistor. Then how to identify their values by using that color coding, or if it is a coil wounded on somewhat that plastic bobbin or somewhat that we can say ferrite core materials, then the value of that inductors are given by the manufacturer, and the various materials used already I told. Then series parallel equivalent of that inductor, and application just like a we can say filters and all that, right? So you might have studied one type of filter in case of rectifiers or in another circuits also, that is LC filter or pi filter, where the combination of capacitor and inductors are used, right? Now, so whenever these two components are used combinedly as a filter, remember the inductor, it should be in series. See, suppose this one is your unregulated power supply, and if you have to use that LC filter at its output to remove the ripple or to smooth the output voltage, then this inductor, it should be in series, right? While the capacitor is, it should be in parallel. If we try to interchange these two components, then the output will be 0. Why? So just imagine if at the place of inductor, capacitor is placed, this one is placed over here. What is the output of this block? That is nothing but rectifier. The output will be pulsating DC. Now already I told, whenever that capacitor is in series, it will going on to block that DC components, and the purpose of this circuit is what, to obtain the output as DC, right? Now what is the purpose of this shown circuitry over here? It is used to remove the ripples, correct, or it is acting as a filter. So whenever this inductor is in series, what it will going to do, it will going to pass the DC components very easily, because XL equals to 2 pi FL. The reactance offered by this inductor to the DC component, it will be almost equals to 0. That's why it will be going to pass the DC components, while reactance offered by this inductor to the AC components, which are available at the output of this rectifier, that is this we can say unregulated power supply. So the reactance offered for that AC component, again it will be somewhat high, because that XL, it is directly proportional to F, is it? So this inductor, it will going on to filter some AC components. Suppose few components, AC components, are pass out through the inductors. Again over here a capacitor is present in parallel, so what it will do, it will going on to provide the bypass to that AC components like this. So that AC components will get grounded, while as the capacitor stores the energy and do not pass the DC component, means across this capacitor there will be a stored energy with the polarity like this. So the net obtained output voltage, it will be purely DC, we can say, or that ripples or somewhat AC components or harmonics, it will go on to remove by using this LC filter. So basically these two components combinedly are used as a filter, as well as in tune amplifiers, we can say that tank circuit. For tuning purpose, these two components are connected in parallel with each other to form a tank circuit. So this is again one of the another application of these two components, right? Whenever are connected in parallel, we're going on to form a tank circuit like this, is it? So these are few again the applications of this inductor and capacitor. So I think you might have understood about the details of this resistor, inductor and capacitor. So the first module is completed, which includes that passive components. In next module I will go on to start or conduct from semiconductor, PN junction diode and all that, and the applications of various devices. Okay, so thank you again.